Hello and welcome to this little tutorial. My name is Matthias Koch and today I want to show you how you can get better results when working with Boolean Fracture. So I did a very simple setup right here, and as you can see we get some cool looking pieces, but we also get those little pieces which are very complicated for bullets to simulate and can cause the solver to create some problems. So before you do your sim, you want to get rid of those pieces. One way would be to use a measure SOP and measure, for example, the volume, and then blast all the pieces that are below a certain threshold. But as you can see, we create holes in the geometry. So we need a better way of getting rid of those small pieces without creating those holes. Let's assume that this is the piece we want to get rid of. So the first thing we need to find out is to which other piece we want to connect this piece. Because in fact, we will not delete this piece, we will merge it together with another piece. This is the piece we want to get rid of. And let's say that this is the piece we want to connect it with. So we basically just merge them together and copy the name of one of them to the other, like so. And as you can see, because I visualize the name attribute, those are now the same color, which means they are the same piece. But one problem remains. As you can see, we have those overlapping polys right here. So we can clean this up with a clean SOP and basically just remove those overlapping polygons. So now we have something like this, and that is basically everything we want to do. Because I already have one version of this tool right here, I want to show you how it works in action. So again, we have our basic fracturing, and in the moment this preview small pieces is checked, so it basically lets us view the pieces it wants to consolidate. So we have a threshold value right here. For example, if I would type in this number, it would give me all those pieces, but I would like to have even smaller pieces, so I can type 0 more. This looks like a good selection, so I uncheck preview small pieces, and now it lefts me with the result. And to visualize the result, I do a exploded view, and as you can see, we can't find any of those small pieces anymore. And if we hide this for a moment, we can see here are the small pieces, and if we unhide it, they are gone. So yeah, and that is exactly what we are going to create. So let's jump right in. Okay, let's create a new GeoSOP, create a box, because we need something to work with. We use a VDB from polygons in order to create a volume, but we want to create a fog volume, make it a little bit more high resoluted, and create a scatter. Let's say we want to create like 8 points, and onto these points we want to copy a grid. So copy 2 points SOP. This looks quite good, but we also want to make the orientation a little bit more random, so we use a attribute randomize, plug it in, and we don't want to randomize the color, but instead we want to randomize the normals, and we use the distribution function inside sphere. To make it a little bit more interesting, let's create a mountain SOP and increase the resolution of the grid by a bit. Okay, that's good. So now we can create a Boolean Fracture SOP. This is our base geo, and this is our cutting surface. And we get something like this. We can put a exploded view in order to visualize it. And as we can see, we got some interesting pieces, but we also got some very small pieces. So let's start. Create a null. And the first thing we need to do is create a measure sub. We want to not measure the area, but instead measure the volume. And we want to do this per piece. But our piece attribute is not class, but instead name. So from now on, we want to work in a subnet. So select the measure SOP and click on the create subnet icon. Go on to edit parameter interface. I like to make all this stuff visible. And let's create a float, call it min size, also at the top, min size. And basically this is the threshold value where we want to say pieces that are smaller than this size should get consolidated. So I think a range from 0 to 0.1 is quite nice. And as a starting point, we can say 0, 1. Okay. So let's create a integer input. Call it iterations. I think range between 1 and 1000 is quite nice. Default is 1. And also a toggle, which we want to call visualize and visualize. Okay, check this one. And I like to give my subnet a color and give it a name. Consolidate small pieces. That should work fine. Okay, let's clean this up a little bit. Here we have our measure SOP. Okay, the next node we want to create is a group SOP. Basically, we want to group all the small pieces. So we call the group small. So name this create small group. And go up one level. We want to copy our min size. And go into the base group and say add volume smaller than paste relative references. So this will only select the small pieces. And to visualize this, we can use a last SOP and select small and delete non-selected. And those are pretty much all the pieces we want to consolidate. So this already is quite good. This already is our preview function, so we just want to create a switch. Plug this in and plug this in. Excuse me, we want to have the group right here, and then just the blast node, which we can also call visualize on the left side. Make it green because it's visualizer. Okay. And what we also want to do is we want to create an output for this subnet. So just type output. And basically what this allows us is that we can have everything we want selected, for example, the measure SOP. But if we go up one level, it would still output the stuff that's coming into the output SOP. So we also have this visualize checkbox. We want to copy this one and paste it into the switch. So right now it's off and it is looking at input 0, which is wrong. We basically want to reverse this, and we can do it by putting such a sign in here. Okay, if we go up one level, we already have this visualize function working. Nice. Okay, let's make some room in here. We will need it. And we want to create a for loop with feedback. Plug it in here and plug it in there. We have here this number of iterations. We basically made this field for that. So we want to copy it and say paste relative references. So at the moment we have one iteration. This is fine. And basically the first thing we want to do is we want to find out which pieces should be connected. Let's create a attribute promote. We want to promote from primitive to point, and the attribute we want to promote is name. And we in fact don't want to delete the original. Let's make a subnet out of this one. Go into edit parameter interface, deactivate this, color the subnet, and name it find on pieces. Okay, dive in, clean this up a little bit. So, and now in order to find out which pieces need to be connected, we need to create a wrangle node. But first let me show you what exactly it is what we are going to do. This is our small piece we want to consolidate with another piece. But there's not just one piece, we have 3 pieces we can connect it with. So the question is, to which of those pieces we should connect our piece? And the answer is we need to find out which piece has the strongest connection to our piece. For example, piece 1 is connected on 2 points to our piece. Piece 2 is connected on 1, 2, 3 points. And piece 3 is connected on 1, 2, 3, 4, 5 points. So piece 3 has the most connected points and therefore is the winner who gets connected to our piece. Okay, let's create an integer variable, call it nearpoints, and use the nearpoints function. Compress F1 in order to get help. Our geometry input is 0. Our position vector is at P. And our max distance is something very, very small, like so. And basically this nearpoint function will also return the point where we are currently. So we want to remove this point from the list. We can use the function remove value for that. Compress F1 in order to get help. So the first input is the array we are dealing with, and the second input is the value, which in this case is pt_num. Okay, now we can iterate over the array with a for each loop. And we need to create a second array. This time it is a string array, call it names. Now we need to find out the current name. So we create a string variable called name, use the point function again, and access the name attribute. Now we need to check if the name we just found is already in our list names. To do that, we can use the found function. So let's create a new variable. Call it integer found and use the find function. Again, we can press F1 in order to get help. And we need the array, which is names. And the target will be our name. If the find function doesn't find anything, it will return a negative number. So we can write if found smaller than 0, we can append to our names array our name. Everything left to do is now create a new attribute. We can call it S for string, then square brackets to make sure it is a array, at con pieces. And this is just names. Okay. Let's hit apply and go into a geometry spreadsheet to check what we did. And as we can see, each point now has a list of pieces it is connected to. Okay, that is basically that. Let's name this one find pieces per point. Let's create a split node. This basically just splits the geostream into two separate streams, and as a divider we want to select a small group. So now we have on the left side all our small pieces, and on the right side we have the rest of the geo. For the left side we want to create a for each name primitive loop, and this will now run over all the small pieces. Okay, so what we now have to do is we need to find out to which piece our current piece has the most connections to. So for example, if I look at this, I can see that there are 4 connections to piece 1 and 3 connections to piece 16, and so on and so on. And we basically need to find out to which of those pieces it has the most connections to. So in order to do that, we are going to create a wrangle again. But this time we create a detail wrangle. And we now have to run over each point. So we create a for loop. Type integer I equals 0, I is smaller than n points, input geo is 0, and increase I plus 1. This endpoints function just gives us the number of points on geostream 0. Now we need to access the con pieces array of this point, so we create a new string array, call it con pieces, and we use the point function in order to access this point. I forgot square brackets right here. Now we need to iterate over this array as well, so we use a for each loop. Piece. And now we basically need to count each of those values. So normally you would do a 2-dimensional array for this, but because Vex don't has 2-dimensional arrays, we will do 2 separate arrays. I just see I made a mistake here. This should be a semicolon. Okay, let's create our first array, which is string called pieces. And our second array is integer amounts. Okay, now we basically need to check if our current piece, our con piece, is already in the pieces array, and if it is not in the pieces array, we will add it to it. For this, we use again the find function. So we create a new variable, call it integer found find. Use the help. First input is the array we want to check, and the second input is our value. So now let's say if found smaller than 0, we will append it to our pieces array, and we will also append something to our amounts array, and we will append a 1 because we have this piece one time. So, but if this is not the case, press Alt-E to open a separate editor window. This makes it a little bit more easy to watch. And now we basically just want to take amounts, and we want to use found as an index, and we want to increase it by 1. Now, in order to check this, we can create a string attribute, call it pieces equal to pieces, and a integer array called amounts, make it equal to amounts. Okay, and let's just watch. Okay, there's an error. I forgot the @ sign. Okay, more errors, yeah. Yeah, this basically needs to be a string as well, not an integer. Okay, now it should work. So let's look here. So we can basically see we have piece 16 5 times, piece 1 4 times, piece 5 3 times, and so on and on. Okay, let's go back into the editor. We don't need those attributes anymore, but we can basically comment them out if we want to access them later again. So now we basically need to find out which piece has the most amount. Let's create a new integer, call it max amount, and make it equal to -1, and create a new string variable, call it max piece, and make it equals to an empty string. Now create another for loop. In fact, we can really copy the for loop from here down there, and we just need to change this section right here, type len and our amounts. Basically, this will give us the length of the array right here. So if the array has like 3 values, the length would be 3. So now we can say if amounts on the position I is bigger than max amount, then max amount equals amounts on the position I, and also max piece equals our pieces on the position I. And now we just need to create a new attribute, call it s@conpiece equals max piece. Okay, accept. And now we have just this piece 16. And this basically says that piece 16 is the piece we want to connect with. Okay, now that we have that, we can delete some attributes. We can delete the connected pieces, and we want to attribute promote our detail attribute that we have just created down to the primitives. So before we had our information here in the detail tab, and now we have it on our primitives. Yeah, here it is. Okay, and that's basically all we have to do for the moment. But in order to make this run pretty fast, we can use a compiled SOP. So type compiled and plug it in on the top and also on the bottom. And make sure to select the bottom of the for each loop and check multi-thread when compiled. And this way, this will run very, very quickly. Now let's look at this stream. We still have the connected pieces attribute right here, so we want to delete it as well. You can use the same attribute delete for that. and we don't have the connected piece prim attribute that we have just created. So create a attribute create. There it is. And we want to call it connected piece. Make it a primitive attribute. It should be a string and make it -1. So that is that. Now we can merge those streams back together. So, like that. Perfect. Okay, now that we have this, let's go to the top of our node tree again. Pull this down a little bit. Drop an attribute delete, because we no longer need the point attribute name. Can get rid of it. Let's drop a extract centroid and put the method to bounding box, because it's a little bit faster and we don't need the precision of center of mass. We also transfer some attributes. We want to transfer name and conpiece and also the small group. Now control middle click on the extract centroid and click on the connected piece attribute. This will create a marker for this attribute. Open the display options. Click on the pen besides name. We want to edit the name marker. We want to change it from color to marker. We want to enlarge the size a little bit. And we also want to make this marker a little bit bigger and also change the color to maybe orange. Yeah, as we can see now, each piece is represented as a point and has those two attributes on it. And basically those attributes define the connections between the pieces. Okay, to make things a little bit more clear, go up all the way into the GU level. And let's create a new box. Make it pretty small, like 0.01. And add a copy SOP. Copy and transform. And let's do like 6 copies. Copy the uniform scale, copy parameter, and paste it in transform C. Paste relative references. Maybe minus. Okay, now we basically can copy it a few times. Okay, repeat this node and basically paste relative reference on the Y and delete it here. Maybe do like 4. And then do another copy and transform. Make 2 and put it up a little bit. I don't know, like small amount, really small amount. Okay, something like this. This is nice. Okay. Let's create an assembly SOP. Okay, that's pretty good. Okay, let's put this into this input. So basically we just created a little test geometry which will help us making adjustments to our current tool. Okay, let's jump in there. So now we have piece 4, which would like to be connected to piece 5, and piece 5 would also like to be connected to piece 4. But piece 3 would also like to be connected to piece 4, and piece 2 would also like to be connected to piece 3. So we can't connect all these pieces in one iteration, because we would connect piece 4 to piece 5, but piece 3 would also be connected to piece 4. So we would end up with the same geometry multiple times, and it would be a complete mess. Let me draw this for you. We have this is piece 1. This is piece 2. and this is piece 3. Those two pieces would like to be connected, but those two pieces would also like to be connected. So if we would run this, the connection of those two pieces would look something like this. And the connection of those two pieces would look something like this. We have duplicated this object, which is just false. So instead, what we need to do is we need to first connect those two pieces, and then in a second iteration, we would need to connect those two pieces. But how can we do this in Houdini? Okay, so what we want to do next is create polylines between the connected pieces in order to get a sort of network that represents our connections. We do this by adding a Rango SOP and let it run over points. We just want to create a line if our connected piece is not -1. Don't forget colons because this is a string. Now we need to find out the point number of the connected point. We can do this by creating a variable named con, and we can use the function find attribute val. This function basically lets us search for a specific attribute value. So geostream is 0, attribute class is point because it's a point attribute, attribute name is name, and value is s at con piece. And we type in 0 because we just want the first match. Okay, now we need to create the line. We can do this by add prim, and we can press F1 for help. So this seems quite good. So we want geostring 0, type is polyline, pt0 is add pt num, and pt1 is con, and that's basically it. So it looks something like this, and it does represent all the connections we have. So click on display primitive numbers, and you will see that we sort of get these double numbers. For example, here at 5, there are clearly two numbers on top of each other, and this is because this piece is connected to this piece, but this piece is also connected to this piece. So our Rango SOP has created two polylines. To get rid of this double polylines, we can create a clean SOP, and we basically want to uncheck everything but fix overlaps, and we also want to uncheck delete overlap pairs. So now this looks a little bit better. In order to connect as many pieces as possible within one iteration, we can use the technique of graph coloring. With graph coloring, each primitive or point gets assigned a color, so that two identical colors can never be found side by side, and as few colors as possible are used. Mathematically, this is a very complicated problem. Fortunately, Houdini already provides a note for this. If you want to learn more about graph coloring, check out the video link in the description below. What we can do now is drag down a graph color sub, and for better visualization, control middle click on the node itself and click on color. Click on sort output by color, and as you can see now, most of the prims have a 0, which means that we get most connections by using color 0. So we can basically blast everything else. Blast, check delete non-selected, run over primitives, and set add color equals 0. So, and those are basically the connections we want to solve in the first iteration. drag down an attribute create and name it con piece, make it a string and make it -1. So now every con piece attrib is set to -1, but that is fine. Drag down a group delete and delete the small group. Now drag down a wrangle. Let it run over primitives, and we need to find the points that are belonging to the primitive. So we create a new integer array and we use the prim points function. GString 0 and we say add prim now. Now we need to get the name of the second point. And we can use the point function to do that. And now we need to set the connected piece attribute on the first point. So we take the function set point attrib, and we can press F1 for help. This is GString 0, the name is piece, points 0, value is name, and mode is set. And we also want to set the small group, so set point group. Can again press F1 for help. And we take geo handle 0, name is small, point number is points at 0, and value is 1, mode is set. And we want to copy this set point group, and this time we want to call it used, and we want to pack point 1 in it. Okay, so now it looks something like this. At this point we can pretty much delete all the polylines. We can do this with an add SOP, like so. And now we can basically transfer all those attributes back to the original geometry. So let this run over primitives, and in order to find the corresponding point we need to use the find attribute value function again. So we create a new variable, integer, Okay, now we need to access the connected piece attribute. So we type s add con piece equals point. Actually, we need to put ones in here. Okay, now we need to transfer the point groups. We can do this with a function. The function is called in point group. You can again press F1 for help. Geo is 1, group name is small, and point number is point. And if so, we can type add group underscore small equals 1. And we can do exactly the same thing for the used group. Okay, we should do a colon there. Okay, let's check. Yeah, groups got copied. Also connected piece got copied. Yeah, that looks good. And call it transfer. So and that's basically all for this node. So let's create a output and jump up one level. Okay, now create a split node. Change group type to primitives, and we want to use the small group. Let's create a subnet out of this node and open edit parameter interface and disable all those. Dive in, clean this up a little bit, and let's create another split node. Put it into the second output, and this time we want to use the used group. Change it to primitives. Let's do another for each loop, for each named primitive. Let's create another input, so click create meta import node and change the method from fetch metadata to fetch input. Drag it over a little bit, put this into this. Now we have those two geostreams. And basically on this input we have our connected piece information, and we now need to isolate this piece from this geostream. To do that we create a mirror, put the first input here and the second input there, and let it run over primitives. First we need to find out the name. For this we can use the prim function. And now we can write a condition. If name is not equal our print name, we want to remove the print. So, and this is basically the piece we want our piece to merge with. Call this node isolate. The next thing we want to do is we want to copy some attributes from this stream to this stream. So we create another wrangle, put the second input right there, call it transfer attributes, and we want to let it run over the primitives. The first information we want to change is the name, so create s at name equals print. And we also want to transfer the volume, and we want to add it on top of our existing volume. So we write f at volume add equals print 1 volume 0. Okay, let's check the geometry spreadsheet. We changed it from piece 3 to piece 16, and we also increased the volume. Perfect. Okay, now we can merge those two streams. And as you can see, this is the position where we merged the two pieces, but because they both have the same name now, they have the same color as well. But we still need to remove the overlapping polygons. So let's drop down a clean. uncheck remove generate primitives, and uncheck remove unused points, check fix overlaps, and also check consolidate points. So yeah, and that is basically all. So let's clean this up a little bit and also drop down a compiled block in order to make this run faster. Don't forget to check multi-thread when compiled. Okay, now we can merge those two streams back together. Put this in there, this in there. Let's drop down another clean SOP. Uncheck everything. Check remove attributes and remove groups. And we want to remove one piece, the small group and the use group. And let's drop down a output and go up one level. Give it a color. Call it combine pieces. Let's clean this up a little bit. In the moment we have just one iteration, but it is also possible to have much more iterations. We want to avoid useless iterations, so we want to set a stop condition. To do this, create a last node, plug it in there, and we want to delete non-selected, and we want to delete the small group. So basically, when we have no small pieces anymore, we can stop our loop. And we can do this by going into this node, go to add spare input, drag and drop the blast, and go into the stop condition. Now write n points on geostream -1 equals 0. And this will stop our loop when there are no small pieces left. Okay, let's put this up a little bit and drop down an attribute delete. We want to delete the volume. Okay, and that's pretty much all. So now we can enter a really high number into the iterations slot. And as you can see, we had some small pieces, but if we activate our tool, all those small pieces got consolidated. And in order to get a better understanding on how the tool exactly works, let's connect our test geometry back in. And as we can see, something is not correct. So we need to fix some of the mistakes I just made. So the first mistake I made is that we need to create the small group new in each iteration. So copy this node down here, plug it in there, and put this to the side and connect this to the measure SOP directly. The second thing I forgot is in the find connected pieces subnet. Before we transfer our attributes onto this geostream, we need to drop down a group delete and delete the small group. And there's one more thing that's causing problems in the moment, and that is the clean SOP. Because internally the clean SOP works just like the fuse SOP, and it uses the standard values of the fuse SOP. And for our geometry that is very, very small, the snap distance is set to high. Drop down like 2 more zeros, uncheck recompute effect normals, and plug it into the clean SOP. On the clean sub, uncheck consolidate points. And that is basically all. If we now go up again, we should... Okay, let's go up all the way to the geo level, frame it, and as we can see, this is our geometry as we started. In the first iteration, it fused together some pieces. In the second iteration, even larger pieces are created, and so on, and so on, till all the small pieces get resolved. Okay, for iterations we can type in a really high number, like 1000, and this should basically work in each scenario. Okay, thank you for your time, and I hope this tool is useful to you.